You're listening to the Ready Set. Oh, nope, wrong podcast. Good morning, good evening, good afternoon, wherever you are. Happy Tuesday. This is the Believe in Serverless podcast. I'm your host, Alan Helton, AWS Serverless hero, ecosystem engineer at Momento, and all around just fun serverless guy. I'm here today to talk to you about you. This podcast is designed to help catch you up on what you might have missed in the Discord community. We're here to talk about what you talked about last week. We're here to answer any unanswered questions. And we're here to discuss some of the live streams that happened last week. And then we'll talk about some of the ones that are going to be taken on, the ones that are going to be going on this week. Now, I am recording on Monday, which is a holiday here in the United States, Labor Day. And normally we have two hosts on the show, but on holiday weekends where everybody usually travels, very hard to coordinate two of us together. So I'm coming at you today solo, and we're gonna roll with it today as best as we can. Before we get into it, let's thank our sponsor. Today's episode is brought to you by Momento, the cutting edge platform redefining real time data management. Whether you're building high performance gaming apps, media platforms, or enterprise grade solutions, Momento has you covered with its ultra fast, reliable services that scale effortlessly with your needs. With products like Momento Cache for lightning fast data retrieval, Momento Topics for dead simple real time event delivery, and Memento Storage for robust, cost effective data management, you're not just keeping up with the competition, you're leading the charge. Memento's pay for what you use model ensures you're only paying for the performance you need, with no hidden costs or surprises. That's why some of the top enterprises across the globe are choosing Memento to power their most demanding, mission critical applications. Ready to experience the future of real time data? Head over to gomomento.com to learn more and start for free. Memento, because in the world of real time, every millisecond counts. Thank you, Memento, for your ongoing support and sponsorship of this podcast and community. All right. So now we're going to talk about the new members. We had 8 new members join us last week, bringing our total in the community up to 875. So welcome, Syed, Jedberg, Ryan Chance, Aaron Mikhail Staples, Samir Dedia, 3YQ Dosator 16 OG, quite the name, very impressive, and Flux. Very happy to have you in the community, and I look forward to learning from you best we can. So let's go ahead and jump in and talk about what you guys talked about last week. The first thing that caught my eye in the conversation last week was using email as a primary key in a user database. This was posed by, I think, Juan Garcia in the general channel, and he just asked that question: can I use email as a primary key in a user database? And in general, the community opinion was no. And there's a handful of reasons why that is. The first one being emails can change. And as a junior developer, when I was first building a user-based system, uh, I didn't think that emails could change. I thought, okay, I've never had an email change. So we're not going to do that. We can use email as a primary key. And funnily enough, the I went and implemented this user database using email as a primary key. And from the time I started the project to the time I had ended the project, a developer on my team got married. Goes to show that it does happen all the time. This is something that, whether you realize it or not, it is a common thing in people's lives. People get married, people get divorced, people just change their name randomly. Emails can change. So that's one of the big reasons why you would not use that as a primary key. Other reasons that people brought up inside of the community was that people could have multiple active email addresses at any given time. I know that I do that personally. I have a spam email address and I have my real email address, and I use the two interchangeably based on things that I'm signing up for. So if your system allows for that and track back to an individual user, then, well, you kind of out of luck if you're using that as a primary key. Now, what a lot of people do, what I've ended up using in all the systems that I build, is using the user sub as a primary key, and a sub is an abbreviation for subject, and it's generally considered to be the unique identifier for a given user. These are generally assigned by your providers like Okta and Cognito when a user signs up. So you have your email address as a mutable key, and then you have your sub as your immutable key that you can use reliably as a unique identifier for a person. Another things that they discussed in this thread that I found interesting was it was an AWS specific implementation, but if you do need to do things like look up users by email address, you can do things like DynamoDB GSIs to be able to query for that, since GSIs, primary keys in a GSI can change. They don't have to be unique and they can change. So if you do have an access pattern where you're looking up a user by an email address and you're using AWS and you're using DynamoDB, certainly could do something like that. So anyway, I thought that was an interesting conversation. It's something that most of us will run across at some point in our development careers, and it's a very easy answer to pick off and give reasons why you should not be using email as a primary key. Another conversation that was had that I've run into, and it was a living nightmare to get out of, is reaching the upper limit of CloudFormation resources in a stack. This is again, I think, was brought up by Juan Garcia, and he just this past week ran into the upper limit for resources when deploying into AWS in a single stack, which is 500 resources. So he has I think he's using a SAM template, which is an abstraction that sits on top of CloudFormation that, makes it a lot easier to tie components together, tie resources together in your AWS account. And what ends up happening is when that gets deployed into CloudFormation, the abstractions expand out into what those resources are. And you can, I don't want to say easily, but you definitely can run into a situation where you grow past 500 resources in a specific stack in any enterprise application where you're always maintaining that stack. Entropy happens, new features happen, it will continue to grow, and you end up running into that 500 resource limit. So what do you do? What do you do when you run into that? It's really disheartening when you go to deploy a stack and it fails because it says you have too many resources. So one of the one of the answers that was provided by the community, I think this was from Andres Moreno, is that he splits things out by nested stacks. So you have one more or less driver or root stack, and then you have a bunch of resources contained in an inner stack that's executed by that outer stack. So you still have referential integrity. You can still output and import resources, but you do get past that 500 resource limit per stack because they are nested in technically separate stacks. Another thing that people do and people recommended is splitting your resources into stateful and stateless stacks. Now, what does that mean? Stateful resource is going to be things that manage state. I hate using a word to describe a word, but things like your database are generally stateful because they have to maintain state. They have that information that persists and needs to be accessed at any point in time and get the current state. So what a lot of people do is they create things like SQS uh, DynamoDB tables, RDS tables, uh, Elasticsearch or OpenSearch uh, clusters, VPCs, things that are all out there that are provisioned that don't really change. They basically just need to be deployed the one time. They put those in a single stack. Things that don't change. They go out there and they sit and they do their thing because you don't have anything. They don't change ever. Those go in one stack. And then you also have another stack for your stateless resources and for the things that are dynamic and change. Consider that to be your serverless functions. So that could be Lambda or API gateway as well, because you're going to be maintaining an API, adding endpoints, removing endpoints over the life cycle of your app. So those go into another stack where when you deploy, it goes and does the diff and, in general, changes. So that's one of the strategies that people go with the stateful and stateless stacks, and that will split your resources out and help you manage that 500 upper limit. So what's interesting though is I was reading through the comments and the chat history around this conversation, and doing so over a big application really leads to a lot of complexity. And I think what a lot of people might not realize is when you get into a big, large enterprise application that's hundreds of services and that has thousands of resources deployed, there's no getting around complexity. People say that, yeah, I can't do that because it becomes too complex. Well, things of that size are complex by nature. So you have to kind of take that into consideration when you're splitting things out. But one of the things also that you need to consider is not to over optimize too early. Last week, I believe it was in the podcast, I was talking with Danielle, and we had a short conversation about a Twitter post from DHH where he said, if your SaaS application is under $1 million in annual recurring revenue, you don't need more than one server. You can have a super beefy server that runs your compute, your storage, and your job processing, all kind of self-contained. And the benefits of that are you have basically zero network latency for inner operations, and really it's all about performance at that scale. Because if your database is on the same machine as your compute, you can get that data really fast and serve that back to your customers as fast as possible. But conversely, you have a high blast radius where if it goes down, your whole app is going down. But I think the point that DHH was making in that is that if you're less than $1 million in ARR, does it matter? I go back and forth because there's, of course, trade-offs, and there's some mission critical things that really can't go down, that you need that redundancy for. But when thinking about splitting things into stateful and stateless stacks, trying to over optimize to reduce complexity 10 years down the line, well, your app might not exist in 10 years. You might fundamentally change what you're doing in 2 years and be dealing with this extra overhead early on. So, take that into consideration. Jan Kui he has a great blog post on this where he recommends keeping your stateless and stateful resources together in the same stack. And his reasonings in, high level are you can deploy and everything goes or everything doesn't go. Yeah, so it's basically like a transaction. Your CI/CD is simpler because you're not managing multiple stacks. And then in general, it's easy to create ephemeral environments because you just have one stack to deploy and you're good and you're up and running. So things to consider back and forth. I don't think there is a good answer. Of course, with everything, it depends. So take think about that one when you're building. Watch the amount of resources that are getting generated and figure out, do you need to add that complexity? One other thing before I move on from this topic is the idea of using other third party providers that don't use CloudFormation, things like Terraform. Now, Terraform does not have an upper limit for the number of resources that you can include in a template because it uses the SDK, and the SDK for the individual resources. So if you're creating Lambda functions, it will use the Lambda SDK to create and update and delete those functions. But while there is no upper limit, it does have its limits. So things like if you surpass, I was reading a forum on this just this morning. If you pass about 1,000 resources in a Terraform template, your performance is going to nosedive. The SDK inside of AWS and really anywhere you go, uh, Cloudflare, anywhere, there is a limit to performance and throughput. So if you start slamming the cloud provider with update requests and add requests, it's going to throttle you. So do keep that in mind. This is going to be a problem pretty much wherever you go. And really, it just comes down to resource management and managing complexity. Okay. That's a fun one. Clearly, that one has a soft spot in my heart. But we're about to move on to something that has another soft spot in my heart because this is something that I had to deal with when I was both an enterprise architect and an engineering manager for app teams. And this is schema validation for APIs. Now, the conversation again revolves around AWS implementations, but this goes for all of the different cloud providers. Where do you do it? Where do you do schema validation for request response type of APIs? This is going to be things where maybe like a REST API. So Amazon API Gateway has a feature that does schema validation at the gateway level. So before it invokes your resources at all, it will go and it will validate the schema of the incoming request. And if the schema doesn't match, it will reject it, return a 400 response to the caller, and not even invoke your downstream resources. Now, what this does overall is it reduces the number of calls to your resources, ultimately saving you money. But what it also does is it saves time and development effort and maintenance of your code because you're not adding that schema validation inside of a Lambda function or whatever compute is being invoked by your API gateway. So that was ultimately what I did when I was running engineering teams was I said, let's skip it. We started off by adding schema validation inside of all of our Lambda functions. And that added a lot of overhead for us. We had to account for that development time. We had to account for building specific JSON schemas that we had to maintain inside of the code and figure out how to import and share across Lambda functions. When ultimately what we decided doing was build that into our open API spec and have API Gateway use that at the gateway level. However, the community conversation was really interesting because I feel like I was in the minority in that conversation. Most of the people that were engaging in that discussion said, no, no, no. You have to do your schema validation inside of the compute itself, which it has its merits. Lee Gilmore was the main driver of this conversation, and he talked about hexagonal architecture, where you have different abstractions really around the way that you build your compute, where you have your ingest layer, and then you have your data layer and your business logic. And for an architecture that practices hexagonality, definitely a word, uh, the API gateway the schema validation really belongs inside of the code because you can adapt and change the type of compute you're working on like that, where it doesn't matter. There's no code change. You can go from Lambda to a container just by changing the IAC and your code works. Now, I don't disagree. I don't disagree with that. But I also go back to the conversation we just had about managing complexity unnecessarily and creating more of an issue for yourself before you need it. If your app never outgrows the initial scale, which hopefully it always does, I genuinely hope everybody outgrows and has unicorns every application that they make. But pragmatically speaking, that won't happen to a lot of us. And a lot of us won't get out of that scale where we need to move from functions to containers or something else to manage costs a little bit more effectively. So building that logic in, it might be a premature optimization. So, that's something that you need to consider once again when you're building is managing the scale, looking at your forecast, how are things going to go? So again, it's a trade-off for compute and developer maintenance and movability. Now, one other thing that I found interesting in this conversation was the discussion of what to use for this schema validation. And really, the conversation revolved around two different packages, and they were both for JavaScript. One being AJV, which stands for literally another JSON validator, and Zod, which I don't think that's an acronym. I think that one is just called Zod. But those aren't really comparing apples to apples. That's like comparing apples to crab apples. Uh, AJV is it's been around for a really long time, a really, really long time, and everything supports it. And its main thing is super fast JSON schema validation. And that's it. That's what it does. It has support for custom keys and all that stuff. It can't be around for this long without having support for something like that. But that's what it does. And Zod, on the other hand, really is for TypeScript. It focuses more on TypeScript validation. So it's working with types rather than JSON schemas. So if you're not using TypeScript, Zod is going to lose a little bit of its potency. It's also not as fast as AJV. That said, Zod is built into the Lambda Power Tools for TypeScript, and it's used in the schema request validator. So, it's there. If you're already using Lambda Power Tools, which you should be if you're building in AWS, definitely consider using that. It's hard to make a case against TypeScript and against types, especially when working in an enterprise environment. So, just take those two things into considerations. They aren't really one for one comparisons, but uh, you know, do take a look and figure out which one best works for you. Now we're going to move on to unanswered questions. So this is the section of the podcast where there's a lot of questions that get posed in the community, and not all of them get answered. And there was one specific question that I saw that just was completely ignored for whatever reason. And I just wanted to address it real quick because it's an interesting conversation that has a whole bunch of different answers, like everything we've already talked about today. So this question was posed by Marmota in I think it was the API channel this week. And they said, I'm working on a basic WAF rule for throttling app sync calls by IP address. Lambda functions in my system are also making some app sync calls. How do you generally avoid internal system calls being throttled? A secret header or something else? So the question here really is, how do you make a distinction between internal service to service calls and external calls? Now, there's a lot of different options for this. And I have built personally a handful of these different ones. And it's hard to say which one is better. Again, it always comes down to your use case. So, of course, the answer is it depends. Now, one thing that you could do in answering directly to Marmota's question is you could have those Lambda functions that are calling your public API fire through a static IP address. That's absolutely something that you can do. You can create a VPC. You can put those Lambda functions inside that VPC and have an elastic IP address on top of it. That way, all the requests coming out of it come from a single IP address. Then you could build that rule into your WAF, which for those of you that don't know what that means, that's a web application firewall. And you can have that traffic have different throttling rules than, let's say, external callers. So that's one way. Can't necessarily say that's the simplest way, but that is the most direct answer to Marmota's cause. You can have that static IP address and then change the throttling rules there. Another thing that you could do, and this is more of your common implementation in these situations, is you can have a private API. So you have your public app sync API, and that can be used by integrators. It can be used by your front end. It can be used by whoever. It's your public API. But you could have also a private API, could also be AppSync, that sits side by it, that's used exclusively for internal use. And that would have a different auth mechanism. It might not have a three-legged auth flow like your other one. It might just have a basic server to server auth where it's an API key or a client ID and a client secret. That way you can, more agile or move a little bit more agile between your backend services. Another thing that you can do when you have that private IP or private API is have different queries. Now we're talking about app sync, so I'm trying to use GraphQL specific terminology. You could absolutely have different queries and mutations in your private API compared to the public one. Things that have more administrative focus or have access to private things. You could I don't necessarily want to say bypass some of the PII rules, but you do have basically privileged callers that can get to information a little bit easier. Now, one of the tricks that you have to do when you're maintaining a private API next to your public API is really consider, when do we keep these private APIs private and when do we move them public, if ever? One of the big things with API design and API maintenance is as soon as you move something public, it can never go away. Amazon is a really good uh, case study in this, except for recently with retiring some of their services. But once it's out there, it's out there. And if you make a breaking change, you generally have to provide a way to get at that old functionality and also maintain a way to get at the new functionality. So versioning, and all the different ways that you can do versioning. So again, this is one of those classic examples of managing complexity, which, you know, do you do these side by side or do you go for the simple static IP address out of your Lambda function? There are other things that you can do as well in situations like this. Like you could use a secret header. You could, but the downside of using a header for this type of workflow is going to be branching logic inside of your application code. So your application code, whatever you're using to do the compute behind your AppSync API, is going to have knowledge of what that secret header is, check to see if it exists, and then go and do something else to fulfill that request. So I'll generally stay away from things like that and see if we can maybe do a little bit higher level or up the stack type of implementation. Okay, so there's a my best attempt at an answer to that unanswered question. Now, the next phase, we're going to talk about the live streams that we had last week. We had 3 live streams for the Believe in Serverless community. We had Aaron Mikhail Staples from LaunchDarkly go and build a uh, basically show us how to use LaunchDarkly inside of an application. Now let's take a look at that clip real quick.
We can see I have 0 model here. I'm just using basically placeholders. I'm like, use model. Have a great time. I'm controlling the temperature. I'm controlling the tokens, the length of the input. I'm doing that all within LaunchDarkly, not my actual application itself, which is kind of nice.
You could do something like this if you're building, let's just say, a SaaS app where you have different tiers of accessibility. Really, you have your free tier
Hmm.
down to whatever instant model is that costs nothing to run, and then your premium members can get access to Sonnet 3.5 or whatever it was. I guess Opal was a pretty expensive one there for a minute. So this was a conversation that Erin and I were having. I was coding along with her inside that session where you can use things like feature flags or really LaunchDarkly is a feature management service. It's not just feature flags, but you can use it as mutable or changeable environment variables. So what I really liked about this specific implementation that she was showing us is she had an LLM. She had an endpoint that was calling whatever LLM generative AI model to detect sentiment. And she had the model name, she had the number of tokens it was allowed to do, she had the system prompt. All these things were managed inside of LaunchDarkly itself and then passed into her compute at runtime. So what's really cool about that is you can have these flags that are evaluated at runtime. And this is kind of like the example that I mentioned in the clip, where if you have like SaaS tiers, if you have a pro tier or a free tier, you can absolutely evaluate that against LaunchDarkly to say, okay, this is a paying customer. Not only is this a paying customer, this is like the top tier customer. Let's provide them with a top tier answer. So you can have the most state of the art LLM as a result do your sentiment analysis because this person is paying a lot of money to use your services versus something like a free tier user, which can use a free tier level LLM to do sentiment analysis. And what's great about that is you don't have to do code changes. You don't have to do branches in your logic. You don't have to do any extra work. You just have to call this, application configuration service that manages and tracks that all for you. So big fan of LaunchDarkly in general, but also just the concept of flag management and environment management, where you can make changes on the fly or make changes without having to do a redeploy. So clip number 2 is from a live stream that Andres Moreno and I did last Friday, where we were assessing Claude artifacts or Anthropic artifacts using Claude Sonnet 3.5. Now, the gist behind this is that the artifacts are basically longer form files that Claude generates for you and gives to you kind of separate from that chat window. Andres and I are trying to build an entire application using it. So let's go and take a brief glimpse at the reaction to what Andres and I had when we were using it. This is pretty awesome.
Just
Just
doing
watching it
everything.
code the whole app. We're gonna be done in 15 minutes, and 10 of those minutes was just us talking. Look at that. It's even using parameterized environment variables. It is using Node 14, which I think is interesting if you look at that definition file that it's building out.
Wow. Okay. So we did a lot. Let's go back to
Yeah.
this. So let's analyze.
So Andres and I have this application that we like to build whenever we're assessing frameworks. It's a GPS app where it's just a real simple API that ingests GPS data points and then renders them on a map, just like following a route. And every X number of data points, it starts doing some calculations on how fast is the GPS moving, what's the average velocity, how far has it gone. And we asked Claude to build that. I just copied and pasted the requirements doc that we have in GitHub and just said, build me this app. And that clip that you listened to was us being just utterly bewildered at how fast it launched into building the entire app in one go. And we didn't give it a lot of implementation details intentionally because I wanted to see what it did just off the cuff. So we did say AWS, and it built things using Lambda and CloudFormation. So after that initial, oh my gosh, it did everything for us, we gave it a little bit more information, like use AWS SDK v3, use SAM template, use Node 20, build unit tests, and it did. It would go through and build. I think it built like 8 different files for us, just with one prompt. And it would iterate on those 8 files, and it told us the file directory to put them in, like the folder structure and the solution. And it rocked, honestly. My biggest qualm with it at this point in time is that it's not integrated into VS Code. So any iterations that you're going to do basically are bootstrapping because once you take that code away from Claude and put it into VS Code or whatever your code editor is, you're kind of on your own to maintain and make updates to it, unless you bring that code back into Claude, say, here, I have this file and now I want to make a modification to it. I think as soon as something like this hits VS Code or something that has integration abilities, we're going to see a complete change in the way that we build things as developers. I'm incredibly excited for it, honestly. I think this is a massive developer productivity boost. And I think it will help as well normalize the code writing. The last live stream that we had last week was from Aditya, I believe that's how you say his name. And he's from AppWrite, which is a cloud vendor. Let's have a look at what he was talking about.
AppWrite is a modern backend as a service platform, which has offerings for authentication, databases, storage, functions. There is a service that lets you get real-time events across your project. There is a messaging service if you want to implement and integrate different offerings for push notifications, emails, SMSs within your application, and so on. And AppWrite's actually really cool because it's open source. That has allowed us, of course, to get feedback and critiquing and support from the community across the world.
Now, what I haven't used AppWrite before, and it sounds like, DigitalOcean, like Amps, like Lolo Code, all these other competitors that are complete environments to build in the cloud. It has services for pretty much everything that you would need to build an actual production ready service. What I like about AppWrite is the fact that it is, community driven and community led as far as what the features are that they implement, but they really prioritize developer experience. In the hour long conversation that Danielle had with Aditya last week, he was able to completely build, test, run, and deploy a URL shortener, which is a great example. It's a good example of a multifaceted app that you can do really quick. And it was just so impressive, the developer experience, how fast everything is, the local dev, which is really hard in the cloud, of AppWrite. So definitely give it a try. Like this is something to use if you're building dev projects for your on your own. Like if the next time you go and build a side project, try using AppWrite. It's a pretty cool system. Okay, so we are at the end of this episode, and I want to talk about the things that are coming up this week. So today, if you're listening on Tuesday, Danielle Heberling has a talk that she's doing called "Rethinking Serverless," which is something that I think we all need. It's a conversation with her and her musing. She has fantastic insights and just thoughts on the community and tech in general. So she's going to talk a little bit about serverless today at 11 a.m. Pacific time. Again, if you're listening to this, not if you're listening to this on demand, uh, it might have already passed. You can absolutely go and check it out on YouTube. All of our live streams are there. And on Friday this coming week, Andres and I will be back for our last part in our AI Code Companion series, where we're going to try to build a complete app using Amazon Q. So, we were just talking about Anthropic Artifacts and being able to create something in seconds for that GPS app. We're going to do the same thing, but with Amazon Q, the partner that is actually integrated inside of VS Code. So we're going to try to build the same thing. We're going to see how fast we can get where we need to go, see how fast to compare the quality of the code from Amazon Q and artifacts, but also see how easy it is to iterate on your design. So we'll get a bootstrapped application, we'll make some changes to it manually, and then subsequently we will add features via Q to see if it can take what we have and modify it on the fly. So that'll be happening on Friday. As far as live streams go this month, September, happy September, is a data month. So we are going to be focusing on the different types of data storage that you have. And this isn't necessarily just cloud. So we have things like NoSQL from Alex Debris. We're going to have sessions on that. We're going to have Postgres and learnings from NoSQL from Pete Naylor. We're also going to have a talk on time series databases, what those are useful for, and pragmatically building on top of them from one of the DAs at InfluxDB. And then we're going to be talking about cache data, what it is, and how you actually do have a use case for it from Memento. In addition, we're going to have a few other talks around data. That's kind of just going to be the overall arc this month. So lots of really good lessons from extremely intelligent people going to be happening throughout the rest of the month. Now, if you haven't joined the Discord, highly, highly recommend joining there. We have a very active community. You can come in, you can lurk, you can actively participate, you can submit for giving a live stream. You can reach out to me, you can reach out to any other community champions, and we'll get you hooked up. But if you're interested and you haven't joined, believeinserverless.com/community will take you straight to the Discord. So please consider getting in there. Another thing I want to remind everybody of is we do have a Google Calendar that you can subscribe to, where you can see all of our live streams that are upcoming directly integrated into your calendar. So if you go to believeinserverless.com/calendar, you can see all of those rendered on the screen, but you can also have a subscribe link there on that page that will hook you up on your Google Calendar so you can see them as you go. You don't have to keep going to that page. Anyway, thank you for listening. This was your weekly roundup. Hope you enjoyed listening to me talk for 40 minutes. But thank you for continuing listening. Thank you for your help. Thank you for your engagement, and happy coding. We'll talk to you later.